हेलो स्टूडेंट, स्टार्ट करेंगे चैप्टर 12 इलेक्ट्रिसिटी पार्ट 3 ऑफ 3. इट इज़ द लास्ट पार्ट ऑफ योर चैप्टर. We have already discussed about resistivity and numericals based on resistivity, right? Now we are going to start our discussion from heating effect of electric current. Heating effect of electric current means when electric current flows through a conductor, then it produces some amount of heat, right? And that heat depends upon the magnitude of electric current flown through the conductor, and resistance of conductor, and time for which the electric current is flown through the conductor. Now when an electric current is passed through a high resistance wire, it becomes very hot and produces heat. This is called the heating effect of electric current. I think it's clear enough now. हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट किसे कहते हैं? जो हीट प्रोड्यूस होती है किसी कंडक्टर या वायर में, तो इलेक्ट्रिक करंट फ्लो कराने से, उसे बोलते हैं हीटिंग इफेक्ट, राइट, करंट का. इफ़ ए पोटेंशियल डिफरेंस ऑफ वी वोल्ट्स इज अप्लाइड इन सर्किट, अगर कोई वी वोल्ट का पोटेंशियल डिफरेंस अप्लाई करते हैं और उसकी वजह से कोई आई करंट फ्लो करता है कंडक्टर में टी टाइम के लिए, right, then the heat produced by the circuit will be H is equal to VIT, product of all these three: potential difference applied, I, current flown, and T, time for which current is flown. So the product of all these quantities will give you the amount of heat produced through the wire. If we replace this potential difference by product of I and R according to Ohm's law, then it will be modified into H is equal to I square RT. This H is equal to I square RT is what? It is Joule's law of heating, which states that if we put resistance of wire and time for which current is flown through the conductor constant, then the heat produced by the conductor is directly proportional to electric current flown through the conductor, right, and square of electric current flown through the conductor, right. And if we put current flown through the conductor and resistance of wire, all these two constant, then heat produced by the conductor is directly proportional to the time for which electric current flown through the conductor, right, time for which electric current is flown through the conductor. So and if we keep I and T constant, then H is directly proportional to R, which is resistance of wire. So H is equal to I square RT is the formula which explains Joule's law of heating. Basically this formula comes from Joule's law of heating. Now we are having some problems based on this mathematical expression. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Now you are having R resistance, you are having I current, and you are having T time for which current is flown, 30 seconds, right. So R equal to 20 ohm, I equal to 5 ampere, T is equal to 30 seconds. We just need to put all these values in. H is equal to I square RT. We'll get the amount of heat produced through the conductor, which is 1.5 into 10 raised to the 4 joules. You are having calculation here. Now the next point is electric power. What is electric power? Electric power किसे कहते हैं? Electric power work done upon time, मतलब amount of work done in unit time is basically the electric power. It is the rate of consumption of electrical energy, or we can also say that it is the electrical work done per unit time. Electrical work done per unit time is power. So P is equal to W upon T. So ऐसा unit, standard unit of power is watt, right. 1 watt equal to 1 joule per 1 second. So electric power is equal to I square R. Just remove T from H is equal to I square RT, that H will be converted into P. So P equal to I square R or P equal to V square upon R. These two are interchangeable mathematical expression based on by using Ohm's law, right. So 1 kilowatt is equal to 1000 watt. Watt is very small unit, so therefore we need kilowatt at many instances, right. Commercial unit of energy is kilowatt hour. 1 kilowatt hour is basically a unit of energy, not the power, right? Kilowatt means power, but kilowatt hours means energy, right? 1000 watt into 3600 second, and then it is 3.6 into 10 raised by 6 watt second. It means 3.6 into 10 raised by 6 joules, because watt second is basically joules, because watt is joule per second and into second is only joules, because per second and second will be cancelled. Now problem is, an electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. If we are having electric current potential difference, then we need to find out power, right, in 2 hours. So we need to convert hours into second, right, because hour is not the basic SI unit of time. It is second, which is the standard unit. So we need to convert it from hours to second. Then we need to use all these quantities in the formula of power. We know power is equal to V into I. So multiply potential difference with current to get power. It is 1100 watt. Now heat generated is power into time. So power is basically V into I, and V into I into T is heat. Heat is equal to power into time basically. So power is 1100 watts into time is 7200 seconds. So it is 7.92 into 10 raised by 6 joules in standard form, right? So it's clear now. Another problem, an electric heater draws current of 10 ampere from 220 volt supply. What is the cost of using the heater for 5 hours every day for 30 days if the cost of one unit is rupees 5.20? So first of all, we need to use we need to find out the energy units of energy used. Yes, commercial units of energy used, consumed basically, right? So we need to find out kilowatt hours first, then we need to multiply it by rate, like rupees 5.20 into number of units. Potential difference is 220 volt, current is equal to 10 ampere, time is 5 hours. We need to convert 5 hours into 5 hours. No need to convert it, because we need to find out energy units of energy consumed. So first of all, we need to find out power is 2.2 kilowatt, and 2.2 kilowatt power into time is kilowatt hour. It is 2.2 kilowatt into 5 hours, it is 11 kilowatt hours. So 11 kilowatt are basically the number of energy units consumed by electric heater in 30 days, sorry, in one day. So in 30 days it is 3300 kilowatt hour. So cost of one unit is rupees 5.20. Now cost of 330 units is 5.20 into 330, it is rupees 1716. So 1716 rupees is answer, right? It is the amount of, sorry, it is the cost for using heater for 5 hours every day for 30 days at a rate of 5 rupee 20 paise per unit. I think it's clear enough now. If you find any difficulty in understanding anything, you may ask again. So that's it for today, and thank you very much. चैप्टर भी इसी के साथ कंप्लीट हो गया. We'll start discussion in next session with a new chapter. So see you then. Thank you.